Conduit bending requires precision, and accurate measurements are the foundation of a successful bend. Firstly, consider using a conduit bender measuring tape. These tapes are specifically designed for conduit bending and often have measurements marked in both conduit sizes and degrees of bend, simplifying the layout process. Secondly, accurately measure from reference points. Determine the center point of the desired bend and measure from this point to the end of the conduit. This will help maintain accuracy throughout the bending process. Thirdly, utilize a square to project the measurement line perpendicularly to the conduit. This technique ensures accurate offsets and prevents skewed bends. Fourthly, clearly mark the conduit. Use a marker or scribe to mark the measurement line and the precise location where the bend should occur. The markings are crucial for visual guidance during the bending process. Shifting focus to the physical bending process, selecting the correct bender is paramount. Different types of benders are designed for different conduit sizes and bend types. Using the appropriate bender ensures efficient and accurate bends. Secure the conduit properly. Clamp the conduit securely within the bender to prevent any movement during the bending operation. Movement can lead to inaccuracies and wasted material. Heating the conduit may be necessary for larger conduit sizes. A torch can be used to heat the conduit, making it more pliable and easier to bend, particularly for larger diameters. Follow the marked measurement line meticulously. Bend the conduit along the marked measurement line, ensuring that the angle conforms to the desired specifications. Visual alignment is key to achieving the intended bend. When precise angles are required, use a protractor or bubble level. These tools will verify the bent angle, ensuring that it meets the project's requirements. Always practice on scrap conduit. Before attempting to bend live conduit intended for installation, practice on scrap pieces to get a feel for the bender and the bending process. This will reduce errors and material waste. Applying a conduit lubricant can significantly reduce friction and make bending easier, especially for larger conduit sizes or more complex bends. Always check the bend radius. Ensure that the bend radius of the conduit meets the requirements outlined in the relevant electrical codes and standards. Non-compliant bend radii can cause damage to conductors and create safety hazards. After bending, secure the conduit with straps or hangers. This prevents the conduit from moving, sagging, or becoming damaged after installation. Proper support ensures the long-term integrity of the conduit system. Before bending, consider the type of conduit you will be working with. Rigid metal conduit, or RMC, is a heavy-duty option often used in exposed or harsh environments due to its robust protection against physical damage. Intermediate metal conduit, or IMC, is lighter and easier to bend than RMC while still providing significant protection. Electrical metallic tubing, or IMT, is the lightest of the three and is typically used in concealed locations where physical protection is less critical. Each type of conduit requires slightly different bending techniques and tools. When measuring for bends, it's important to understand the concept of take-up. Take-up is the amount of conduit that is consumed in the bending process. This varies depending on the bender and the size of the conduit. Consult the bender's instructions to determine the correct take-up for your specific setup. Failure to account for take-up will result in inaccurate bends. For example, if a bender has a take-up of 5 inches for 1 inch conduit and you need a 90-degree bend, you must add 5 inches to your desired measurement to compensate for the material consumed during the bending process. Understanding shrinkage is also crucial for accurate conduit bending. Shrinkage refers to the distance that the conduit shortens along its original axis after a bend is made. This effect is most pronounced in 90-degree bends and offsets. Again, consult the bender's instructions for shrinkage values to ensure precise measurements. To calculate the developed length of a bend, which is the total length of conduit needed to create a bend, you must consider the radius of the bend. The developed length is calculated using the formula developed length equals 2 pi r times angle divided by 360, where r is the radius of the bend and angle is the angle of the bend in degrees. When making offsets, which are two bends that bring the conduit parallel to its original path, you need to consider the distance between the bends and the angle of the bends. The distance between the bends is determined by the desired offset height and the angle of the bends. Common offset angles are 30 degrees and 45 degrees. To calculate the travel, which is the distance between the two marks for the bends in an offset, use the formula travel equals offset height divided by sine of the bending angle. The gain, which is the amount of conduit saved by making the offset, is calculated using the formula gain equals offset height times cosine of the bending angle. When bending saddles, which are 3 bends used to navigate around an obstruction, similar principles apply. The center bend is typically a larger angle, while the 2 outer bends are smaller and equal in angle. The calculations for travel and gain become more complex with saddles, so it's important to use a conduit bending calculator or reference materials. Consider using a level and a plumb bob when making bends and vertical runs of conduit. These tools will ensure that the conduit is straight and plumb, which is essential for a professional-looking installation. Use a backup shoe when bending conduit near a coupling or fitting. The backup shoe provides support and prevents the conduit from collapsing or deforming during the bending process. When making multiple bends in a single piece of conduit, plan the sequence of bends carefully. It's often easier to make the most complex bends first while you still have plenty of straight conduit to work with. Before making any bends, inspect the conduit for defects such as dents, kinks, or rust. Damaged conduit may be difficult to bend accurately and may compromise the integrity of the electrical system. If you encounter a difficult bend, don't force it. Forcing a bend can damage the conduit or the bender. Instead, reevaluate your measurements and technique and try again. Using a hydraulic bender can make bending large diameter conduit much easier. Hydraulic benders provide more power and control than manual benders, reducing the risk of errors and injuries. When working with aluminum conduit, be extra careful to avoid overbending. Aluminum conduit is more susceptible to kinking and cracking than steel conduit. When bending PVC conduit, use a hot box or a heating blanket to soften the conduit before bending. PVC conduit becomes pliable when heated, making it easier to bend without cracking or deforming. Allow the PVC conduit to cool completely before removing it from the bender. This will prevent the conduit from springing back to its original shape. After bending, deburr the ends of the conduit to remove any sharp edges or burrs. This will prevent damage to the conductors when they are pulled through the conduit. Use a conduit reamer to deburr the inside of the conduit and a file to deburr the outside. Inspect the finished bend carefully to ensure that it meets the required specifications. Check the angle, radius, and straightness of the bend. If the bend is not accurate, make adjustments as needed. When installing conduit in wet or damp locations, use watertight fittings and sealants to prevent moisture from entering the conduit system. Moisture can damage conductors and electrical equipment. When running conduit underground, bury it at the proper depth to protect it from physical damage. The required burial depth varies depending on the type of conduit and the location. Consult the relevant electrical codes for specific requirements. Always wear appropriate personal protective equipment, including safety glasses, gloves, and a hard hat when bending conduit. Conduit bending can be a physically demanding and potentially hazardous task. Be sure to follow all safety precautions to prevent injuries. If you are unsure about any aspect of conduit bending, consult with a qualified electrician. Conduit bending is a critical skill for electrical work, and it's important to learn how to do it safely and accurately. Remember that conduit bending is a practical skill that improves with experience. The more you practice, the more proficient you will become. Take advantage of opportunities to bend conduit even if it's just for practice. Consider enrolling in a conduit bending course or apprenticeship program to learn from experienced professionals. These programs provide hands-on training and instruction in all aspects of conduit bending. Remember to consult the National Electrical Code, or NEC, and any local electrical codes for specific requirements related to conduit bending. These codes provide detailed information on conduit types, bend radii, support requirements, and other important considerations. Staying up to date on the latest code requirements is essential for ensuring safe and compliant electrical installations. In addition to the NEC, there are many other resources available to help you learn about conduit bending. These resources include textbooks, online tutorials, and manufacturers' websites. Take advantage of these resources to expand your knowledge and skills. Proper planning is essential for successful conduit bending. Before you start bending, take the time to plan the route of the conduit run and identify any obstacles or challenges. This will help you to determine the types of bends that will be required and the order in which they should be made. Always double-check your measurements before making any bends. Accurate measurements are critical for ensuring that the finished conduit run will fit properly. Use a conduit bending calculator to verify your measurements and calculations. These calculators can help you to avoid costly errors. When making bends and long runs of conduit, use a pull box or junction box to break up the run into shorter sections. This will make it easier to pull conductors through the conduit. Support the conduit properly to prevent it from sagging or becoming damaged. Use conduit straps or hangers to secure the conduit to the building structure. The spacing between supports should comply with the requirements of the NEC. When running conduit through walls or floors, use a conduit sleeve to protect the conduit from damage. The sleeve should be slightly larger than the conduit to allow for expansion and contraction. Seal the ends of the sleeve with a fire-resistant sealant to prevent the spread of fire. When running conduit near heat sources, use a high-temperature conduit that is designed to withstand the elevated temperatures. High-temperature conduit is typically made of steel or aluminum. When running conduit near corrosive substances, use a corrosion-resistant conduit that is designed to withstand the corrosive environment. Corrosion-resistant conduit is typically made of PVC or fiberglass. Ground the conduit properly to provide a safe path for fault current. Use a grounding bushing or a grounding lock nut to connect the conduit to the grounding system. The grounding system should comply with the requirements of the NEC. Label the conduit clearly to identify its purpose. Use a conduit marker or label maker to create labels that are easy to read and understand. The label should indicate the type of circuit that is running through the conduit and the destination of the circuit. Keep your conduit bending tools clean and well maintained. Clean your tools after each use and lubricate them as needed. This will help to ensure that your tools are in good working order and will last for many years. Store your conduit bending tools in a safe and dry place. This will protect them from damage and corrosion. Inspect your conduit bending tools regularly for wear and tear. Replace any worn or damaged parts immediately. This will help to prevent accidents and injuries. Follow the manufacturer's instructions for operating your conduit bending tools. This will help to ensure that you are using the tool safely and correctly. Never attempt to modify your conduit bending tools. Modifying your tools can make them unsafe and can void the warranty. If you are not comfortable using conduit bending tools, seek professional training. There are many qualified instructors who can teach you how to use these tools safely and effectively. By following these tips, you can improve your conduit bending skills and ensure that your electrical installations are safe and compliant. Remember that conduit bending is a skill that takes time and practice to develop. Don't be discouraged if you don't get it right away. Keep practicing and you will eventually become proficient.